Welcome. So in this video, we'll be answering this question before us. It says if sine of a is equal to 0.2 and our a is between negative pi on 2 and pi on 2, then cos of a must equal which of these? So first thing that we need to recognize here is that this question relies upon the Pythagorean identity. So let's write that out now. Okay, having now written that out, let's now sub in the values that we know. So we're told that sine of a is equal to 0.2. So that means I can come here and say 0.2 squared plus cos squared a equals 1. 0.2 squared will be 0.04 plus cos squared a is equal to 1. I now am going to subtract 0.04 from both sides. So I'm going to end up with cos squared of a is equal to 0.96. I now will square root both sides, and I'm going to end up with plus or minus the square root of 0.96. Let's see if I can write that a bit neater. Plus or minus the square root of 0.96. Now, this is where most people just leave their question, but you have to decide whether it's going to be plus or minus. And the way that you decide that is by looking at your domain here. So if I was to come here and just draw out my unit circle, like so, and like that, and then say I exist between pi on 2 and negative pi on 2, well, pi on 2 is up here and negative pi on 2 is here. So that means that I exist between, and let me get another color here, I exist between here and here. So in other words, I exist either in the first or fourth quadrant, and I know that cos is going to be positive in both my first and fourth quadrant because it's the positive x values here. So that means my answer is going to be, and let me change back into my color now, it's going to be cos of a is equal to the square root of 0.96. It's positive, which means a is going to be my answer. Now, we can actually, we're finished the question, that's done. But if we did want to be a bit more precise here and say which quadrant it's going to exist in, because we know that sine of a is equal to 0.2, sine is my y, so it's going to be here, right? This is going to be 0.2. So that means it is going to exist in my first quadrant. So that really doesn't help us with the question, but just so you know, that means my cos is here. So that means if I was to draw my triangle, it's going to look something like that. But that's neither here nor there. That's just kind of show you how we can utilize everything that we're given to be more precise in what we're dealing with. But at the end of the day, as long as you know that it's going to be positive, because in the first or fourth quadrant, cos is positive, that's good enough. Now, you might be asking yourself, could I answer this with my cas? You can. Let me show you how you would go about that. So you would come here, and you would type in the following. You'd go menu, algebra, solve, and I know it's 0.2 squared, so let me put that in. It's going to be 0.2 squared. Then I'm going to plus onto that. Now, instead of putting this in cos squared a, what I'm just going to put in is just x. I just want to know what x is. X squared is equal to 1, and I'm solving that for my x. And as you can see, I get both a positive and a negative out, which is fantastic because that's what we should expect, plus or minus something. But you see how here I got the square root of 0.96, and over here, I've been given an approximate. Well, the reason for that is because if I was to show you for a second, if I went the square root of 0.96, they're just given me the approximate of 0.96, the square root of 0.96. So this is the same as that. I think that might mislead people. They might jump to b because b kind of looks the same, even though, if we word around this, it would be 0.98. Nevertheless, you just kind of have to be aware of that and make sure you don't make any silly mistakes with that. But yeah, this is how you would approach it if you were to do it like this. But most of the time they're after exact values and not approximate. So doing it by hand might actually be useful in this regard. So with that being said, hopefully you found this helpful, and I'll see you in the next one.